Okay. So this is going to be section 5.6, and what we're going to be doing is adding and subtracting fractions, but what we need to do is go back to this concept of an LCD. And yesterday we did a little bit of talk about the difference between factors and terms. And in this case, we have to be very careful because when we're getting an LCD, we're dealing with factors and factors only. So let's go ahead and just do a real simple one. Say something like, what happens when we have something like 1/6 plus 1/3 plus 2/4. Well, actually 2/4 is already simplified. What would be the LCD in this case? And why is that?
12. Because all of them go into 12.
Okay. It's also called the least common multiple. All right, but it's the smallest number that all of these numbers divide into. Another way of looking at it is if you take all the factors of the denominators. For instance, 6 has got a 2 and a 3. 3 has just got the 3, and the 4 has got a 2 and a 2. Basically, what we're looking for is we need one of each. We need one of each factor, and as many as any of the denominators have. For instance, this one has 2 2s, so our LCD would have to have 2 2s in it too. So what I call it is the best collection, right? So you get every one of these factors in the greatest number of each, the largest number of factors that any of these numbers have. So we have a 2 and a 3, but we have 2 2s. So what's going to be 2 times 2 times 3? So we can also do this LCD thing by looking at the factors and looking at which ones are missing. So let's go ahead and move right to the beginning. We go back to the beginning. When you look at this, unfortunately, a lot of you have the ability to look at these numbers. The human brain, this is one of those times when the human brain is amazing. You look at this and you go, oh, LCD 12, right? Okay, but what I try to do is kind of break it down because the factors that we're going to be dealing with are a little bit more complicated. What I wanted to do is kind of give you another way of looking at it. And the other way to look at it is if I factor everything, like I'm doing already, like I'm doing with those numbers, if I factor everything, break it down into these parts, what I notice is that the LCD 12 comes from this. It's one of each type of factor, of the factor denominator, and the greatest number that any one denominator has. So we have 2s and 3s. What's the most number of 2s? 2. Most number of 3s? 1. So what we get is 2 times 2 times 3, which gives us the 12. Got it? So that's why work. I know it says we have to discuss this. We can discuss this with your neighbor, but let's go ahead and why don't you just take a moment? Actually, let's just go ahead and do this. If you could pair up you two, 2, 2, or 3, 2, 2. All right, we're missing Landon. And I know. You can do it. You guys can, but anyway. I'll go ahead and start you with the X's. Now, again, what I want is...
I think you mean a typo on number 1.
No.
You got 13 over 20, and then the back.
Okay. Let's remember, guys, the LCD is one of each factor, and the greatest number of factors any one number has. So we need an X, and we have a 2, and no one has more than one 2 or more than one X. So that's it, 2X. All right? So how would I rewrite these two fractions? How would I rewrite the two fractions? It's going to be 3 over 2x, but what do I have to do to this?
Times it by 2.
I need to multiply it by 2, right? Then I multiply the denominator by 2, and I get my 6 minus 5 over 2x. All right. Can you guys see if you can't do number 1 and 3? Let me give you a minute.
How do you do it with the square? You just square the 6.
Let's remember, another name for exponent is the number of factors. So how many factors of x are down here?
With times it by x.
Okay, so there's 2 x's. Another way I could have written this, I could have written this, Claire, as I could have written it as plus 2 over x times x. So again, we want one of each factor, just x, and the most that any one denominator has. So it's just x squared, right?
So x squared is your denominator.
Yes, ma'am. So can you guys take a minute and see if you can't work it out yourself? And if you can't, then I'll go over the rest of it.
Did you get it? Yeah. Divided by x and similar piece not this, not even this. Cancel. Then back to like numerator, right? You cancel.
Claire, you done?
Yes.
We're just gonna have this and this.
Will, how you doing?
And you can this by x.
Which one are we going to?
It's not the y side. It's not different. It's not different. Yes, yes. Because
All the way done, Melanie? So what do they, so do they call you Melanie or Melania?
Yeah, it's
you
like
don't do the
different
x.
in America, I guess.
It sounds more Russian than French. Sounds like
It's Italian. 'Cause my
Italian,
parents-
but
My parents met in Italy, so they thought
oh, okay.
telling you to do that. I just
No, why would you do that? You didn't do
Are your parents both Italian?
no. So you know 6x.
Oh,
my
yeah.
dad's French.
Did you do 8?
Lebanese?
She literally did 6.
I used to work with the Lebanese Zaire, yeah.
Okay, so that's what I did.
Trust me, because we have pause here. You
But
never do
Kitty's
this.
way makes more sense. So I feel like this is
I
wrong.
know,
No,
but
mine.
Good food. Okay.
No, why would you do that? That's dumb.
All right. Oh goodness, hockey players. Sorry about that. I should have paused you. Okay. All right. Let's go ahead and discuss your results. What's the? Can I?
That's all I care about.
So Kitty, how'd you do on the first one?
9. I got 13 over 20.
13 over 20. Anyone else? Okay, good. And so I think there's two things to learn here. One of them is, oh, come on, you. I think one of them is that I think the LCD is an easy enough concept, but one of the other things I think you need to get used to is whenever we're adding fractions, just know it's going to take a lot of time. So if I give you as many adding fractions as multiplying fractions, I did the wrong thing. I should give you about 1/3 as many adding fractions and subtracting as multiplying, because multiplying is so much easier, right? But understand that adding fractions is always going to, let it raise that flag, because it's always going to be a little bit of a pain. So let me go to
3.
what is I don't see why it's let me. Oh, I see it. Okay, so now let's go to.
3.
All right, 3. Sorry, 3. Let me let's go ahead and finish. Is going to be we're going to have to get an x. We're going to need an x squared down here, so we need to put an x on the top too. So we got 6x over x squared
Then why did you do that?
plus 2 over x squared. And so total, we're going to get 6x plus 2 over x squared. So good with that?
Yeah.
All right. Now, let's go to this stuff.
Can you wait?
Now, let's go back. Okay. Hopefully,
I knew that was the answer.
hopefully now that we reviewed the concept of factors and terms a little bit better, we can look at this and tell me how many factors do we have on the denominator of this first fraction. How many factors is that? Jake?
2, 1,
1, right? There's 2 terms, but it's 1 factor.
I thought you said term.
Got, all right. And
I'm so stupid.
and therefore we also have just 1 factor here.
Yeah.
Okay, so in terms of the LCD, remember again, we need 1 of each type of factor in the most that any denominator has. So basically it's going to be x plus 3 times x minus 2, right? So let me sit down because it's I scribble a little bit too much. So let's go ahead and as a process, let's rewrite the denominator. So the denominator of each one is going to be x plus 3 times x minus 2. X plus 3 times x minus 2. All right. So what's going to go on the? What am I going to have to do for that LCD?
2x times x minus 2.
Right. I need a factor of x minus 2 on the first one. So I've got 2x times x minus 2.
Plus 4.
And then I got plus here, and I got 4 times x plus 3. Now I need to express it. Step 3. Step 3 is to express it as a single fraction over one denominator, right? And all you guys from dropping down from the accelerator going, whew, this is so much nicer than what I was going through. Okay. Anyway, let's go ahead and rewrite it. And so we're going to get 4x squared, 2x squared minus 4x plus 4x plus 12 all over that x plus 3 times x minus 2. So once the denominators are the same, we can combine the numerators under one denominator. Last step, just simplify everything nicely. This goes with this, and we're left with 2x squared plus 12 over x plus 3 times x minus 2. Now, in a test or something like that, I may tell you how I want to express it. I could ask you to multiply the denominator, but one thing that we should always do before we're totally done is once you got this whole thing together, is anyone seeing anything on the top one that?
Yeah,
we can factor out the 2. And the reason I'm going to tell you to factor out the 2 is that it may be that what's left can reduce the fraction. In this case, it won't, but it's going to be 2 times x squared plus 6 all over x plus 3 times x minus 2. So I'm fine right now keeping everything in factored form, because if we keep it all in factored form, we'll be sure not to miss any factors. But every once in a while, when you take out that 2, you're going to go, oh, whoa, there's another factor that matches, right? So make sure everything's factored at the end so that we don't miss those things. Got it? I want you guys to go ahead and, all right, what's the problem with, all right, before we go too far, number 5. This is always the weird question, but same answer. How many factors do we have here? 1, right? And we only have 1 here as it's written. And so we could just say that the LCD would be this mess times this mess.
We can factor.
But it may be simpler in the long run to factor it and see what happens. Of course, something will happen, right? How do I factor the first one?
X minus 2
It's going to be x minus 2.
and x plus 1.
Who agrees with that? Theon? Yeah?
And second one,
Okay, and the second one is going to be,
x times x plus
yeah, you guys hate this one. You hate factoring these, right? LCDs, right? Least common denominator. No, sorry, greatest common factor.
X plus 1, no, x minus 1. So what?
Thank you. Okay, so because they have a factor in common, we can our LCD can be written a little more simply, right? You guys know that we can always multiply denominators to get a common denominator, but the idea is to get the least common denominator. Always makes it simpler. So let's go ahead and can you guys finish this one?
No.
Really? Really? Okay.
I've ever been confused in this class.
What's that?
It's the first time I've ever been confused in this class.
Oh my God, it really is. That's why I'm surprised that you're asking. Okay, so we need the LCD again. Okay, do you get my rule for finding the LCD?
Yeah.
What's that?
No.
Okay, we can go. When we're doing this one, I say, okay, one of each factor. So we've got 2. We have 3 different factors here. X minus 2. We have an X minus 1 and an X. So we want one of each in the greatest number, which is just 1. So now the LCD I can rewrite the LCD for both of them as, it's going to be what?
X times X plus 1 times X minus 2.
Excellent. And then again, X times X plus 1 times X minus 2. And now what I need to do is to create an equivalent fraction, I need to multiply, it looks like I just multiplied the denominator by X here, right? So I need to make sure I do that to the numerator to make sure the fraction is the same. And what do I multiply this one by? What will I multiply
By X minus.
to go from here to here?
X minus 2.
The X minus 2. Now, Mr. Hawk put this together, and he has been very nice about putting plus signs here. You got to be careful though, because if that's a minus sign, remember that makes everything here negative. All right, but we'll stick with these nice positive signs. So the final answer is going to be X plus. It's going to be 2X. We can simplify it right away, right? Minus 2 over X plus 1. X minus 2. And I should factor the top because I can. See if it matches anything. Does it? Got 2 times X minus 1. So it doesn't, right? Over X times X plus 1 times X minus 2. So, so what we notice here, right, is this stuff's not that bad, right? It's not that bad. It just takes a long time. And so as long as you're not assigned too many of these, it's not bad, right? You could actually play music and do this, right? Let's go ahead. Let's go ahead and take a quick look at these. First off, let's go ahead and factor the denominator. So this is what we did. Factor the denominators. Determine the lowest common denominator. If you need to make a note to yourself right now, is that you got one of each. The lowest common denominator is one of each factor, and the greatest number of any one factor any of the denominators have. Right? Rewrite the fraction with the denominator, and then combine and simplify. And again, I think it's worthwhile to always factor the numerator just to make sure there might not be another thing hiding there. All right, another cancellation. So where are we going from here? Let's look at we have guided practice, and this is for you new students. This is the headphone time. You work together, but also this is kind of a moment to relax and try to get into this, get into the topic. We have also, so is anyone looking at these things here? Are we going to be able to find the least common denominator for a squared? That's a and 2a. Can anyone tell me what they think that the denominator is going to be? One of each factor is going to be 2. We have a 2 and an a, and what's the greatest number? 2, right? And so, all right. So, and looking at the other ones too. Let me see if I can't make sure that you guys understand what's going on here. Are these okay? How many factors in this denominator? 1. Just b minus a. How many factors in this denominator? 1. But guess what? It's a tricky one. Does anyone remember the relationship between b minus a and a minus b? They're opposites. Remember, because look at b minus b, negative a, positive a. They're opposites. So I can do that, right? I can switch one, and I'm going to stop talking in a minute. But what I can do is I can rewrite the. Let me rewrite the first fraction. See if you can agree that this is also true.
Yeah.
Convince yourself that that might be true. And at this point, so what happened? I switched this to the opposite, right? Mm-hmm. Basically, I multiplied this by -1 to get its opposite. But to multiply the bottom by the -1, I also must multiply the top.
not that you both suggest negative.
I could have done either one of them.
Okay.
Yeah, I could have done either one of them. Okay. Okay. So I'm gonna go ahead and sign out on hockey players and ninth graders, and hopefully they'll be able to finish this. Also, before fully done, notice that there is an assignment for you. So let's do what we can to finish this, and then we have the algebra 2. These are the questions that we have posted for you guys. What I'll try to do is I'll take a picture of this and I'll post it on with our homework assignment. All right? I'll take a picture of this. But in the meanwhile, go ahead and do that. And freshman hockey players, Ziggy and Thomas and Landon and Joshua and what's that? Alina and signing off. Take care. Ziggy.